Democritus was one of the first atomic theorists. He knew that if a stone was divided in half, the two halves would have the same properties as the whole. He reasoned that if the stone were to be continually cut into smaller and smaller pieces, then at some point there would be a piece which would be so small as to be indivisible. He called these small pieces of matter atoms. The atomic theory stated that the universe is composed of two elements, the atoms and the void that they exist in and leave. According to Democritus, atoms were minuscule quantities of matter. Democritus hypothesized that atoms cannot be destroyed, differ in size, shape, and temperature, and are always moving, and they're invisible. Aristotle believed that there were only 5 elements: air, which was light; earth, which was cool and heavy; water, which was wet; fire, which was hot; and ether, which he viewed as a divine substance, which made up the stars and the planets. Aristotle believed that all matter was made up of either one of the elements of water, air, earth, and fire, or a combination of these 4 elements, with the exception of stars and planets, which were made of ether. Anton Lavoisier revolutionized chemistry. He named the elements carbon, hydrogen, and oxygen. He discovered oxygen's role in combustion and respiration. He established that water is a compound of hydrogen and oxygen. He discovered that sulfur is an element and helps continue the transformation of chemistry from a qualitative science into a quantitative. In 1772, Anton and other chemists bought a diamond and placed it in a closed glass jar. They used a remarkable giant magnifying glass to focus the sun's rays on the diamond. The diamond burned and disappeared. Anton noted the overall weight of the jar was unchanged, even though all the diamond had disappeared. Whether diamond or charcoal were burned by the giant lens, the same gas was produced. We now call it carbon dioxide. John Dalton said all matter is made of atoms, and atoms are indivisible and indestructible. He also said all atoms of a given element are identical in mass and properties. Compounds are formed by a combination of 2 or more different kinds of atoms. A chemical reaction is a rearrangement of atoms. In 1897, J.J. Thomson discovered the electron by experimenting with a cathode ray tube. He demonstrated that cathode rays were negatively charged. In addition, he also studied positively charged particles in neon gas. Thomson realized that the accepted model of an atom did not account for negatively charged or positively charged particles. Thomson's model of the atom did explain some of the electrical properties of the atom due to the electrons, but failed to recognize the positive charges in the atom as particles. Robert Millikan determined the unit charge of the electron in 1909. Millikan's experiment contained an electric field created between a parallel pair of metal plates, which were held apart by insulating material. Electrically charged oil droplets entered the electric field and were balanced between 2 plates that altered the field. When the charged drops fell at a constant rate, the gravitational and electric forces on them were equal. Millikan found that the charge of a single electron was 1.6 times 10 minus 19 C. Ernest Rutherford is a former student of J.J. Thomson. He proved that Thomson's plum-pudding structure was incorrect. Rutherford named alpha particles as solid substances such as gold foil and recorded the location of the alpha particles on a fluorescent screen as they passed through the foil. Most of the alpha particles passed unaffected through the gold foil as expected. A small number of particles were deflected at an angle, and a few ricocheted straight back. Rutherford concluded that the atom consisted of a small, dense, positively charged nucleus in the center of the atom, with negatively charged electrons surrounding it. Louis de Broglie, his ideas were a basis for developing the wave mechanics theory. This theory has greatly improved our knowledge of the physical nature of the atomic scale. He received the Nobel Prize for Physics on his wave nature of the electron discovery in 1929. He believed that electrons can act like both particles and waves, just like light. He also said that waves produced by electrons contained in the orbit around the nucleus. He discovered that electrons can act like waves, which helped explain some of the things electrons do that we've never been able to explain before. James Chadwick discovered the neutron in 1932. Studying the beryllium radiation with an ionized counter in a cloud chamber, he found that the wax could be replaced with other light substances, even beryllium, and that protons were still produced.